Good morning, students. Today, in this session, I am going to discuss about correlation and covariance. So, what is this correlation and covariance? Both are the measures of the relationship between two variables. What are those two variables in a given data set? There will be two variables in a given data set, that is independent variable, one is dependent variable. We are going to find out the relationship between these two variables using this correlation and covariance. This measures how much two variables vary together, while correlation measures the strength and direction of the linear relationship between two variables. And this correlation value ranges from -1 to 1, with 0 indicating there is no relationship, and positive values indicating a direct relationship, and the negative values indicating an inverse relationship. Several methods can be used to calculate actually this correlation. One that two important are the Pearson correlation coefficient and the Spearman's rank correlation coefficient, and also using scatter plots also we can find out the correlation between two things. But how to understand the relationship between two variables? Covariance is measure of how much two random variables vary together. It is similar to variance, but variance tells us how a single variable varies. But covariance tells us how two variables vary together. If there is a positive value of covariance between two variables, indicates a positive relation. This means if one variable deviates from the mean in one direction, the other also will deviate from its mean in the same direction. A negative covariance between two variables indicates a negative relation between them. So let us find out the relationship between the two features. Let us have, think that we have two features x and y. So by calculating the covariance, we can easily find out whether x and y have a positive relation or negative relation. So when it comes to positive relation, if there is an increase in, if the value of feature x increases, there is an increase in value of feature y, or feature x, there is a decrease in feature x with the decrease in the value of feature y, then we can call the relationship as the positive relationship. Similarly, coming to the negative relationship, if the value of feature x increases with the decrease in the value of feature y or vice versa, then we can call the relationship as a negative relationship. Let me explain you with the real time example. Now we know that we are in summer season and we know how much daily the temperature is. We are reaching till 47. So because of this hot season, obviously there will be an increase in ice cream sales. That is, whenever there is an increase in temperature, there is sales in ice cream also increases. So we can say that this temperature is one variable and ice cream other variable. And because of this high temperature, there is a demand for ice cream sales. So then we can say that these two variables, there is a positive covariance and a positive correlation. In the same way, we are hearing some news that because of this high temperature, some people are dying. So, that is, when there is an increase in temperature, there is some pneumonia problems or some deaths are happening in real time. So we can say that between these two variables, we have a negative covariance and a negative correlation. This is how we are going to describe the relationship between two numerical variables. And how we are going to find out the covariance. That is, covariance between x and y is given as 1 by n sigma I equal to 1 to n, that is x minus mu of x into y minus mu of y, where these x and y are the features of the given data set or given data points. N is the total number of data points, and x, already told you it is feature. Mu of x is the mean of feature x, and mu of y is the mean of feature y. This is the formula how we are going to calculate the covariance between two variables x and y. So let us solve one example. This is a given sample data set where we have x and y values. So first, the mean of x is 33, okay, 33, and then mean of y is 6. Now, x minus x bar is 30 minus 33 will get minus 3. 5 minus 6 similarly will get minus 1. 35 minus 33 it is plus 2. 8 minus 6 plus 2. Likewise, you calculate each and every x and x minus x bar and y minus y bar and product of these two. This x minus x bar into y minus y bar. That is minus 3 1 into minus 3 into minus 1 it is 3. Plus 2 into plus 2 it is 4. Likewise, you calculate all these 5 variables and sum all these 5 variables will get 35. Substitute all these values into this formula, that is 35, and as it is a sample data, yes, we are going to take it as n minus 1. If it is total population only, then we are going to take it as n. As it is sample, we are going to take it as n minus 1, that is 35 divided by 4, 8.75. So we can say that this x and y are positively related. So covariance is measure of how too much random variables vary together. Correlation is the degree of interrelatedness among the two or more variables. And this correlation analysis is process to find out the degree of relationship between two or more variables by applying various statistic tools and the techniques. We can apply many statistics tools and techniques. And this correlation is coined by Carl Pearson in the year 1902. And it is denoted by R. And this value always lies between minus 1 and plus 1. And coming to this Pearson correlation coefficient, it is used to calculate the correlation between the features and it is represented by a P. It always lies between plus 1 and minus 1. If it is ranges between 0 less than or P less than or equal to 1, then we say that it is a positive relationship. And if value ranges between minus 1 less than or equal to P less than or equal to represents a negative relationship. And this is the formula how we are going to find out the correlation between two variables. That is correlation of between x and y is given by covariance of x comma y. In the previous example, we found how we are going to find out the covariance of x comma y. And it is divided by sigma x into sigma y. That is standard deviation of x and standard deviation of y. And these are the other ways to calculate the covariance between two variables. Just make a note of all these formulas, how we are going to find out this correlation between two variables. So let us solve one example. This is a given a sample data set where we have x and y variables. Summation of this is given 8 and the mean of this one is 80 divided by 8, it is 10. And it is 64 divided by 8 is 8. Now, x minus mu of x, that is 10 minus 10, it is 0. 6 minus 10 is minus 4. 9 minus 10 is minus 1. Likewise, you calculate for remaining values. Similarly, here it is 9 minus 8 is 1. 4 minus 8 is minus 4. 6 minus 8 is minus 2. Similarly, calculate for these values and these are the results. Let us name this x minus mu x as A, this as B. Now square all these A values and square all these B values, and this is the square of this A value and square of this B value, and sum all these A square will get 32 as a result. Sum all these B square will get 72. Similarly, multiply A into B will get, these are the values, product of A and B values, this one, and summation of all these values is equal to 43. Now substitute all these values in the given formula, that is this one. We already discussed covariance of x comma y into sigma x into sigma y. This can be represented as 1 by n sigma AB divided by sigma A square into sigma B square. That is 43 divided by, when you multiply 32 into 72, will get to 2304. And when you square root of this, you will get 43. And when you divide 43 by 48, it is equal to 0.985. That is, there is a positive correlation between these two given variables x and y. This is one way how we are going to find out the correlation using the Pearson correlation coefficient. But what is the disadvantage with this? The disadvantage with this is if it will work only if the relation between the features is linear. That is, if there is a straight away relationship is there between two variables, it works fine. But if there is a non-linear data, okay, then it doesn't fit well. So that's why we go for another method that is called as the Spearman rank correlation coefficient. Here, what we will do is, here we'll calculate the rank instead of covariance. And the formula for calculation of this Spearman rank correlation coefficient is given by R equal to 1 minus 6 into sigma I equal to 0 to n d square divided by n cube into n. Or else we can also say it is n into n square minus 1, where n is the number of data points and d is the difference between the rank of the two features. Okay, let us solve one example using this formula. There are two attributes, let us say beauty and intelligence. X represents beauty, Y represents intelligence. Are they related? Are X and Y are correlated? Let us find using this Spearman correlation coefficient. But first, let us represent in the form of a table what is these X values and what is Y values. Okay, then rank these X values. How we are going to rank this? Just look into this column. See which one is having the highest value. Yeah, of course, we have 9.6 as the highest value. So this will be ranked as 1. See for the next highest value. Yes, this one, 8.5. Then it is rank it as 2. Then 8.3, rank it as 3. Likewise, rank from 1 to how many data points you have till that time. So we have 10. So we are going to rank it from 1 to 10. Similarly, for Y. See for the highest value in this. Yes, where it is 81. Yes, 81 is the highest value. So we are going to rank it as 1. Similarly, next to highest is 77. Rank it as 2. Then 76. Rank it as 3. Likewise, rank remaining all from 1 to 10. Okay. Now, the continuation of this. Now, rank X, rank Y. We know these are the ranks we already given, rank and rank Y. Now, find out the difference of this Rx minus Ry. That is 7 minus 6, 6 minus 7. Differentiate between these two. These are the values. And square all these di values. We will get this. And sum all these di values. We will get 2. Now, substitute all these values in the given formula. That is 1 minus 6 into sigma di square into n minus n into n square minus 1. That is 1 minus 6 sigma di square. We already know we got it as 12. And n is, you know that it is 10. 10 square minus 1. And you calculate and check whether you have got the answer. It has 0.98 or not. Okay. So, now, just let us see some more examples. I hope you understood this one, how we are going to calculate using this Spearman rank correlation coefficient. Now, this is one more example. Calculate Karl Pearson coefficient of correlation for the following data. We have X data and Y data. Okay. Just pause for a minute and make a note of these two values. And this is how we are going to find out X value, Y value, summation of these two, X square, Y square, XY. Okay. Sum all these values. And this is the formula. Make a note of this. Coefficient of correlation is n into sigma xy minus sigma x into sigma y divided by square root of n into sigma x square minus sigma x whole square into square root of n into sigma y square minus sigma y whole square. Why I am reading this formula is maybe this picture is not, this image is not clear. Just make a note and substitute all these values into this formula and check whether you have got the answer. It has 0.616. Practice these examples. Okay. Then the next question, let us see the next example. If variance between X and Y variables is 12.5 and variance of X and Y are respectively 6.4 and 13.5, find the coefficient of correlation between them. We already know there is a one formula, this one. Okay. Just substitute those values in this one. That is, covariance of XY is 12.5. They have given variance of X and variance of Y, but we have here standard deviation of X into Y. So standard deviation is, we know that square root of variance is the standard deviation. So simply place it as square root of 16.4 and 13.8. And this 12.5 divided by so and so, you will get 0.8. And solve this and check whether your answer is matching with this answer or not. And another one, find coefficient of correlation between x and y by squares of values method or product moment method. This is the same, but with some difference in the formula we are going to calculate. This also pause for a minute and note down these two variables x and y. And this is how we are going to calculate coefficient of correlation by squares of values method. The names itself indicates squares of values method. That is, given x value, find out the x square. Given y value, find out the y square and product of x and y. And summate all these values, sigma x square, y square and x into y. Okay. And we have a formula n into sigma xy minus sigma x into sigma y divided by n into sigma x square minus sigma x whole square. Okay. Similarly, n into sigma y square minus sigma y whole square. Okay. So place these values and check the answer is matching this 0.97. Okay. This is how finding the correlation using the coefficient by squares of values methods. Okay, you have to remember this formula. There is no other option. You have to remember this. Then one more example of this PSMAN rank correlation. Here there is a score of 5 students in maths and science are given in this table. You know that, okay, we have to sort or don't sort. You have to rank all these values, rank of these maths, rank of science, and find out the difference between the ranks and square of those ranks, and substitute all these values in the given formula, and we got it, the answer it as 0.3. As it is value is near to 0, that we can say that there is a big correlation between the two ranks. Okay, this is how we are going to find out the PSMAN's rank correlation coefficient. Okay. Now the last one, just it is interrelated to this covariance and correlation, but it's quite different, and it's quite easy to understand what is this causation. So this causation, this term generally we will experience in our daily life. As I earlier told you that in the summer, I said that there will be a demand of the ice cream, but there will be also a demand of the lemon also will be there. People will have to have this lemon water to compensate this summer. So we cannot say that as the demand of ice cream is increasing, so the demand of for lemon is also increasing. We cannot say that. This relationship is totally irrelevant. And this relationship is happening. Why there is an increase in the demand of ice cream or demand of the lemon is due to the interference of the third feature, that is summer. Okay, that is what we call it as the causation. So causation is a relationship formed between the two features due to the interference of the third feature. That is what we call it as the causation. It is not, and it is not applicable everywhere. You have to make a note of this. This is the relationship formed between two features due to the interference of the third features. So this is all about what is this covariance, correlation, and the causation. And I hope you understood the concept of and especially the problems what we solve. Keep on solving these exercises on covariance and correlation. Thank you.